What if tomorrow comes alive today? And what if the Super Voltaire planes arrive earlier than anticipated? The zero emissions high speed transport is a hot topic in aviation today. It seems like the entire industry is committed to the millennium goals of wiping clean the sector by swapping fossil fuels with clean energy by 2030. But who has stood out as the pacesetter better than the EADS Company? As the great scientist of the 17th to 18th Thomas Jefferson said, where a new invention promises to be useful, it ought to be tried. Tighten therefore your belt, for in this video, we are about to venture into a flight of tomorrow's invention by the EADS or Airbus that has seemingly been brought alive today. You can pause for a moment and hit the thumbs up, the subscribe button, and the notification bell to get more interesting discoveries in the automobile industry. Aviation is recognized as a sector where emissions have been hard to halt. Till now, no single solution or player has delivered the needed viable idea of cutting off completely the unclean energy. Hence, the sky is now being continually polluted with fossil fuels. And the amount of these fuels used is staggering. Would you imagine that one large turbine-powered helicopter can use a minimum of 20 gallons of fuel per hour, with some going through up to hundreds of gallons an hour? But that is peanuts in comparison to Boeing 747. The jet utilizes approximately 1 gallon of fuel, about 4 liters every second. Throughout a 10-hour flight, it might burn 36,000 gallons or 150,000 liters. According to Boeing's website, the 747 burns approximately 5 gallons of fuel per mile, 12 liters per kilometer. This sounds tremendous, doesn't it? The US alone contributes between 3 to 4% of the country's total greenhouse gas emissions, 202.5 million tons of CO2 emissions, and 23.5% of the world's total. With this saturation of planes in Earth's sky with all their emissions, the EADS, which is now known as the Airbus, has come in handy to save the industry. The company has been warming up lately to produce what could be Europe's first wholly electric powered aircraft. The Airbus group is partnering with the French industry and is now entering the light aircraft market. You should not be confused by EADS and Airbus companies' names, which are used synonymously. Actually, EADS lately purchased 80% of the Airbus shares, hence effectively owning it. In pursuit of its goals of producing purely electric planes, the company has founded its subsidiary which focuses on electric aircraft, the Voltaire. Voltaire was set up to develop and produce E-Fan's variants of planes. Initially, 2 production variants were planned, the E-Fan 2.0 two-seater for use as a trainer, and the E-Fan 4.0 four-seat touring aircraft. And since its launching at the Paris Air Show in 2012, it has since been displayed at trade shows and in group showrooms all over the world. The other variants of Voltaire included the E-Fan, a 2-seat concept aircraft and technology demonstrator, which was first flown in March 2014, and the E-Thrust. Unlike the rest, the E-Thrust will be a 90-seat regional jet, and will be purely based on the principles of the E-Fan. But it's the 2 models of E-Fan 2.0 and E-Fan 4.0 that are being aimed at the general aviation market, and officials say that the prices will be competitive with those of current piston engine light aircraft, at somewhere around $300,000. But as of operations and maintenance, the costs will be notably less than a fraction of those aircraft. The entirely electric-powered planes are projected to be released in the year 2035, and they'll be at the forefront of efforts to meet the European Union's 2050 flight path targets of reducing CO2 emissions by 75%, the NOx compounds by 90%, and noise by 65%. But how is the plane standing out? Let's look at its key features. The E-Fan is of all-composite structure, mainly carbon fiber. This material is particularly known for combining qualities of strength and lightweight into one solid mass. As for thrust, the power is generated by 2 ducted variable pitch fans, spun in opposite directions by 2 electric motors of 30 kilowatt each. Ducting increases thrust while reducing noise, and having the fans mounted centrally provides better control. This allows a cruise speed of 86 knots, 160 kilometers per hour or 99.2 mph. The range is not great so far, with the longest flight by test pilot and designer Didier Eseyne putting only 37 minutes on the electronics equivalent Hobbs meter. EADS says 45 minutes is the best design endurance, to be increased as battery technology catches up with the airplane's svelte aerodynamics. The Voltaire E-fan weighs 580 kilograms, 1280 pounds, putting it solidly in the LSA category. Since the plane will not rely on a traditional combustion engine, it is expected to be noticeably quieter than the current generation of planes, with the majority of the noise coming from the propellers. It also means that refueling is as simple as taking out one set of batteries and replacing them with a new pair. Well, firstly, the aircraft produces no CO2 emissions whatsoever. The Voltaire is going to be powered by a series of 250-volt lithium polymer battery packs made by South Korean company Kokam. The batteries, which are mounted in the inboard section of the wings, have enough power for 1 hour and take 1 hour to recharge. But things don't always go well. In case of an emergency, an onboard backup battery is available to make landing possible if the power runs out while airborne. These batteries are significantly larger than the ones currently found in electric land and water vehicles. In case you thought that the Voltaire bucket was empty, you were wrong. How about a super new E-fan X? But over half a century ago, strange delta-winged aircraft flew in British skies, portending a future of a high-speed passenger flight. These prototypes are the BAC-221, the modification of Ferry Delta II, and the Handley Page HP-115 were tested in the early 1960s to support the development of a supersonic airliner, which would eventually enter service as the Aerospatiale or BAC Concorde. It didn't last. The supersonic future faded with the retirement of Concorde in 2003. However, on 28 November at the Royal Aeronautical Society HQ in London, an agreement was signed. This agreement by Airbus, Rolls-Royce, and Siemens is for a flying a hybrid electric demonstrator aircraft, which is set to fly in 2020 and may potentially be the first British with international partners. The aircraft, which was called E-fan X, builds on Airbus' previous experience with electric flight that has including the smaller E-fan light aircraft prototypes and is part of a new drive at the company to fly, test, and innovate as fast as possible. Mirroring the hyper-quick processes in the tech industry, rumors have it that Airbus has ditched the GA-sized electric E-fan development in favor of pushing ahead with this larger demonstrator. The E-fan X aimed to fly in 2020 after a comprehensive ground test program will be based on a BAE 146 regional jet, with one of its 4 Honeywell turbofan engines swapped for an electric motor and fan. Additionally, a Rolls-Royce AE2100 gas turbine, normally used in the turboprop for the C-130 Hercules, will be installed in the rear fuselage to power a 2 megawatt electrical generator. This will be, says Paul Stein, Rolls-Royce Chief Technology Officer, the most powerful generator ever to fly. Batteries, it is true, are good, but they do not yet provide the range many would like. Lithium-ion ones allow the E-fan to fly for about an hour with a 30-minute reserve. That may be fine for a flying lesson, but not for a passenger airliner, at least according to E-fan X engineers. Advantages of E-fan's electrical car: quieter operations. For decades, the aviation industry has been working to reduce aircraft noise to benefit passengers, airport employees, and those who live around airports. Yet, noise pollution remains a significant problem. In some cases, concerns over noise have even impacted air traffic growth and the vitality of local airports. But the electric and hybrid airplanes will help to solve this noise trouble. Compared to jets and turboprop aircraft, they are much quieter, sometimes nearly silent. Electric planes have the potential to operate closer to cities and dwellings at all hours of the day without disturbing communities and wildlife. Reduced fuel costs. For some aviation companies, the decision to pursue electric propulsion is driven by potential cost savings, not necessarily in environmentalism. Fuel costs are a major variable expense for airlines, and as prices rise, so do the costs of tickets for passengers. For general aviation pilots, high fuel prices can be a significant expense and a barrier to flying more often. The introduction of hybrid or all-electric flight is a step toward making flying more affordable for everyone. Increased reliability. Electric motors are much simpler than complex internal combustion engines. They have fewer moving parts, making them less susceptible to wear and more reliable. The hope is that electric aircraft will require less downtime for maintenance, reducing operating costs. The electric aviation age may still be years away, but the stage is set for the future of sustainable, more affordable flight by the brave pioneers of the electrical craft, the Airbus Company.